Hi Albert, how are you doing? We'll wait a few more minutes for everybody to join, and then we'll talk about Pi0 SSH. Hello, Alex. How are you?
Good, and yourself?
Good, thanks. Got two Alexes. Kevin, hi. How are you doing? So, all right. I'm just gonna go ahead and get started. I think some people will be joining us soon, and so today I wanted to show you how you can SSH into your Pi. As you don't have all your adapter, and if you do, you can connect your Pi 0. But if you don't have it, I can show you how you can connect it via your computer or your laptop. So you can see how that's done. And then I'll talk about the script on how you can automate things. Tomorrow and the following day, we are going to use Raspberry Pi 4. So if you have that, or if you previously set it up, that will be fine. If you have your Raspberry Pi 4, which is the larger one, you can set it up, okay? So I'm gonna pick up where I left off yesterday. We worked on imaging the Pi 0, and I talk about using the Light OS. So I'm gonna go into screen share and then we'll touch on where we left off, okay? And then I had edited the document for the assignment because I worked on the script and it seemed to be fine. So if you check out the assignment, I had added a couple of things, and then I will go over those areas. And then I will also show you how you can SSH into your Pi 4. In the past, I had shown some students on how to use PuTTY. You can use PuTTY on your computer to connect to your Raspberry Pi so you can have access to your desktop, but you can also just use command line. Okay, so you can check out the document. I just updated it last night just to work through some of the issues you might come across. And I rewrote some of the steps for if you already have your Pi 4, what you need to do, and so on. So I'll walk you through that. Okay. So we had left off yesterday with completing the imaging on your micro SD. And I mentioned that you can use Raspberry Pi Imager or you can use Etcher. Whichever works best for you, as long as you can get the image on there. If you're using Raspberry Pi 4, if you didn't do this already, I put another document on there so you can follow the steps on how to image your Raspberry Pi 4. You can do a full version with the desktop, but on the 0, which is the smaller one, what you would have to do is you can either connect it to a monitor and a keyboard, which you might not have the adapter. So what we'll have to do is we will set up a way where we can have it automate with the SSH enabling. Okay. So before you eject your USB, after you burn the image onto your micro SD, what I like for you to look at is we are going to look at step 25. So we're going to move forward a little bit because I want to show you how you can configure it if you don't have a keyboard and monitor connection using your laptop or your computer. And keep in mind that these steps work for Windows 10 or my Windows PC, Mac OS, and some Linux versions. If you're using Chromebook, you might run into specific things. And so if you're using Chromebook, email me and I can give you directions on how to use it. Okay. So I just write the instruction for the mask. However, if you're using Chromebook, you might come across some issues and it requires different steps. Okay, So let's say that we already have the image ready on our micro SD, which is in the USB adapter that we had used to burn the image on there. That's where we left off. Then we need to configure our Raspberry Pi 0W, as we don't have the adapter that we need to plug in our monitor and keyboard. So I highly recommend using Sublime Text, and Sublime Text can be used for programming in different languages. So I put the link here. The reason why we don't want to use Notepad is that Microsoft Notepad, it actually uses Microsoft file system, and then when it writes the actual file, it wants to write it either in text or in its application. So you want to use a general text editor like Sublime Text to be able to write specific file that we're going to put into the micro SD, so it automatically enable SSH for us, and it's going to add you to your wireless network. So if you click on the link for Sublime Text, you can find the version that you want to download. So I'm on my Windows PC. It's going to tell me it's for Windows, but if you're using Mac OS, it should tell you for Mac, and you can download Sublime Text. I found that this is the best way to really write these files. I tried using, the native operating system application, and it didn't really work out. And I had spent hours trying to, work around that, but this is going to be the easiest way for you. So after you have downloaded your Sublime Text, and this is a really good application, I recommend it for programming, then you're going to install it, okay? So go through the installation. It's going to take a few minutes. So after you have the installation done, then you would use Sublime Text. You're going to open it up. Okay, let me minimize this. So here it is, and it's not going to have any title yet. It's used for us to just create file or programs. We can write our code on there. Now, if you take a look at the step, it tells you that after you have Sublime Text, you are going to create an empty file. Okay, and that's important. There's no extension to this file. There is nothing that you need to add, because in Raspberry Pi, when it sees a file called SSH, it's going to toggle on the enable option in the configuration. So if you read the thread and the tutorial, and if you watch some video, they're going to show you the same thing. Okay, so once I have Sublime Text installed, I'm going to open it up, and then I'm going to have a new file. So I'm going to go ahead and click File, and then I'm going to go Save As. Okay, and you are going to point to your micro SD with the image that you just created from the step 1 through 8. Okay, so I burned the image using your Raspberry Pi imager, or you can use Edger if that works for you. So all you have to do is to point it to the location where you want to save this SSH file, which is going to be your micro SD with the image. Okay, and as you notice, you would have all your boot, all your kernel files, all of this already established. That comes with the imager after you completed those steps. So you're just going to name it SSH, all lowercase is fine. And then we're just going to go ahead and click Save. Okay. And you don't need any file extension with that, because there's no file extension to really toggle on. There's no specific file type that we need to toggle on the SSH option. So what you're doing there is when you place the file into your micro SD with the image called SSH, it's just a file. you enable SSH service on your Raspberry Pi, either any kind of version. Okay, so you can do this for Raspberry Pi 4, you can do it for the 3D Plus, you can do it as long as it's version 2 and up. So I'm doing this for my Pi 0W because I don't have a way to connect it, let's say. Then second thing that we need to do is that on the Pi 0W, you cannot, there's no Ethernet connection. In the Pi 4, you can connect it with an Ethernet cable, and it should be able to give you an IP address and connect it to the wireless network that you have at home, or your network that you have at home. But there's no Ethernet connection on the smaller version of the Raspberry Pi, like the Zero. So what you will need to do is you are going to write a script. And this script is going to allow us to add the Pi 0W to our network. Okay, so if you look at, online tutorials and resources, they have additional lines for additional configuration. I really think you don't need that. All you're gonna need is step 27. So I'm gonna go ahead and copy this, and then in my Sublime Text, I'm gonna go ahead and open up a new file. Now for our second file, we are gonna go ahead and add in the script. So what happens is in this script, we are going to create a directory, okay, and under var under run. And we are going to make a file called Wpa Supplicant. The Raspberry Pi is going to use the Wpa Supplicant file to be able to identify which network it can connect to. Now, when you use the Raspberry Pi 4, and if you click on the wireless symbol and you type in your SSID and your passphrase or your PSK, it's the same exact thing. Okay, there are a lot of ways that we can configure the Raspberry Pi using script. So what we're doing here is we are controlling the interface, how it's communicating, by establishing a file called Wpa Supplicant. It's going to be under the run directory, which is going to automate, right? And then the var directory. And this is Linux file system, right? And so for the group, we want it to be netdev, okay? Because the way Linux is designed is that you would have certain permission level, even on the system, it would have certain permission level to really access specific services and resources. So if you had taken the last class, we talked about adding Bluetooth. You really have to enable the permission in order to use the service under group or under specific user. And this is how we would be able to really manage the security with the system and with the object or the entity inside that particular Linux system. So here we would have a group, and we want to use netdev. And this is going to be setting the region. So it's like on your preferences in Pi 4, you would then select the region and you would say it's United States, right? We don't necessarily need to set time zone, because when you connect to a larger network or any network, your system would automatically sync with the time for that network if it's properly connected. So now we would then need to enable the configuration for update. In line 5 through line 8 here, you would see that I have the object called network. And inside this, we would then store the information for our SSID. which is going to be your router SSID, and then your PSK, which is your passphrase that you use to connect to that wireless router. So for your script, you would then need to customize this and make sure that it's in double quotation mark and then, or quotation mark, and then add in your passphrase. So with that, what we're doing is when we drop this file into our image or your micro SD, it's going to automatically connect to the wireless network that you have at home if everything is correctly inputted. Okay, so we actually save a few steps because there's no way for you to really see the Pi interface if you're unable to connect it to the monitor. So we have to set it in the background as a script so that way it runs and it's going to connect. Otherwise, your Raspberry Pi will not be connected to your home network. Another way that you can go about around it is to really, find a way to really look at it. So, you can try to connect with VNC, but VNC itself on the Pi Zero, you have to install it and then enable the server. So this is going to be the simplest way. Do you have any question for me? Okay, so after I have this script written, I would then need to save it as WPA underscore supplicant.conf or config. So configuration file is used to really for setting and putting in configurations for your system. For those of you who took CIS30B with me, right? When we did Ansible, we really established a configuration file for the system to communicate. So think of it like that. It would need to have some kind of reference information to really pull the information to connect to the network. So if you work on, like creating script for, a bunch of different Raspberry Pi to connect to your business network, you would then just establish one configuration file and then you can, drop that file into each of the system, or you can automate it using Python script. So there are ways that we can really simplify the actual operational process in this. So once I have my script written, make sure that you put in valid information for your wireless network here. Okay. And then I'm just going to go ahead and do File, Save As. And again, I'm going to point to my micro SD. Okay. And then I will put WPA supplicant.conf like this. Okay. And then I will click Save. Now, anytime that you need to make, let's say that you change your passphrase down the line, you can go in and you can edit that file, right, by taking out your micro SD, put it into your USB adapter, open up a text editor like Sublime, and then modify this, okay, and then save it as a conf file, and then put the micro SD back, plug it back in, boot it up. And so when you do that, what will happen is during the boot process, number one, it's going to be able to enable the SSH service, and SSH is going to rely on network connectivity because we want to be able to remotely log into the Pi system at some point using our computer. Then it's going to establish communication with the wireless router, and it's going to be able to obtain an IP address as it is going to be part of the network. And so the router, the DHCP, which is Dynamic Host Control Protocol, is going to give out an IP address to your Raspberry Pi Zero. Okay? So once you have that saved, then you can take you can eject your micro SD or your USB adapter with the micro SD, and then take it out, and then you are going to insert it into your Raspberry Pi Zero. Okay. Then you're going to plug in the power cable. That's all you need. And then you're going to power it up. And it's going to go. So as it configures, I'm going to stop share so I can show you what the screen would look like. It's going to give you all the green OK like a normal Raspberry Pi would, but you would find a long line in the middle, and it tells you my IP address is, and it will give you an IP address. Okay? Any question? Okay. So once it goes through the boot process and everything is fine, and you will not be able to see this if you don't plug it into the screen, right? So give it like a few minutes. Okay. And then with what we have done is we established the SSH service in the Raspberry Pi Zero W. We also connect it to the wireless network using the script. Okay. Now, the next part is to really connect to it, and then we can play with it, right? So simply, I'm going to go back to my computer, my laptop screen share here. And then, so what we're going to do is we are going to, after we boot it up, we are going to open up our command line. And if you're using Windows, you just call on CMD for command prompt. If you're using Mac OS, you can just look for terminal. It looks just like the Raspberry Pi terminal. Or if you're not sure, you can search terminal, and it should be in your applications. Okay. So with command prompt open, what we will do is we can do a remote connection to your Raspberry Pi. So you would then use SSH, okay, Pi at the host name that you have is Raspberry Pi, okay, .local, because you're unable to see your Pi, so you have to be able to connect to it using its name. And if you do a .local, it's going to point to the local system that is named Raspberry Pi, and the Pi in the front is simply a user name that's default, right? That comes with the image. Okay, so whatever the username that you have created down the line, you would then need to access that. So what I'm doing here is I'm actually connecting to the Raspberry Pi using the host name, right? And it is a local system on my network. Any question? So since I had tested this and rewrote the instruction, I had swapped the micro SD. So if I press enter like this, it's going to tell me that my key is no longer valid because it's a different operating system or a different micro SD that I have inserted. So what I'm going to do is I'm going to show you you can also use an IP address. Okay, so if you know your Pi IP address, then you can put in 192.168, your actual address. So mine is 17. Okay, and this is a private IP address. It's only going to be valid inside my home or inside your network, right? Like inside my network right now, it is an IP address that I can use to connect the device to my wireless router. My wireless router issue this particular address to it. So in order to communicate with the Raspberry Pi, I would use Secure Shell, which is SSH. And with that, it would require authentication and encryption. So SSH use what's called RSA key, okay? And with that, it's gonna use that key to really establish the credential information, the login information to that particular device. So you can use SSH to connect to other systems like your laptop, from your laptop to your desktop, etc. As long as you know the device host name or your IP address, internal private IP address. Now, when you are connecting to the internet, the router has a public IP, and that's different than the private IP, right? Your smartphone has a public IP because it is part of the public network, and in order to communicate with your service provider like Spectrum from the router's perspective, or Frontier, or whoever that provide your service, or it could be that if you're using your smartphone, you are connected to your mobile network service provider, and they actually issue a public IP. So public IP is different than your private IP. The 192.168.0.x, that's your private IP. It's not designed to be used outside of your network. So beyond your router, that IP it's not really valid. You would have public IP that's given to your device, like your router from your service provider, okay? And they would have a set of IPs that they are dedicated to give. So, and most of the time now they're using IPv6, which uses hexadecimal values instead of what you see in front of you is IP version 4, right? And it is a 32-bit address. So IP version 4 is old, it's already maxed out, but people still use it. So that's a little bit of just networking information for you, okay? So if you are successfully connecting to your Pi using its host name or using its IP address, it's gonna prompt you a password. Keep in mind that Linux, when you type in your password, the cursor doesn't move. So if you mistype, it's gonna, you have to press enter and then it's gonna prompt you again. But after a few times, it's gonna time out, right? It's gonna, and then you're gonna have to restart your Pi and try to reconnect again. But if you type in SSH Pi at raspberrypi.local or the IP address, and it doesn't give you the password prompt, that means that you are unsuccessfully connecting because we're unable to see without the monitor, right? So what you would need to do is you would need to take a look at the Wpa Supplicant file and also your SSH. Don't save SSH with any extension. So here I will go ahead and type in my password for my Pi, which is Raspberry as a default. And then for yours, the first time that you connect, it's going to say that it's going to want to establish a key. You're going to have to press Y, yes, to really establish a key. Once you establish a key, then it's going to be able to communicate. So now it gives me the terminal of the Pi 0, right? This is the terminal, and I can start working on it. Okay, so when you see this, you would know that you are inside the Pi now. You remote into it. You use the terminal to connect to it. And everything that we can do on an application interface, we can do in command line. If you know how to work with command line. So after we connect, you should see, right, the path of your Pi. So then I can do like sudo apt update, and then it would just update my Raspberry Pi now. Okay, So once you are connected to your Raspberry Pi, another way that you can find out its IP address, once it's already connected to your wireless network, you can say IP address, 2-word, in command line. And on Linux system, it would be able to show you that, or you can do ifconfig. Ifconfig will show you more of a detailed prompt, right? So you can also, and it would tell you which system is connecting, and it would keep a log of it. So you can see that my Windows PC is at .16, and then my Raspberry Pi is .17. Okay. And so now I'm already in my Raspberry Pi 0W. I can do update. I can do, I can also run upgrade. And upgrade sometimes takes a little longer. And so as long as you have network connectivity and internet connection, it's going to be able to pull that. Okay. I can also install Python 3, such as sudo get install, right? Python 3. Okay. So, and if you have Python 3, because Raspberry Pi comes, you might have heard this if you took the other class or my Python class. Linux and Mac OS and Raspberry Pi, which runs Debian Linux, has Python 2.7 pre-installed. So you can always use Python on those systems, but they are version 2.7 by default. So if you want a newer version 3 is different than version 2, right? Syntax and form-wise is different. So you have to specifically add Python 3 by doing, in Raspberry Pi, you would do sudo apt-get install Python 3. On Mac OS, you would have to use wheel, or if you have pip packages, you can do pip, right? Which is a way that we can install Python packages in most command line. Any question? Okay. So now you can see how you can enable SSH using just a file. You can also write script to add that device to the network, or the Raspberry Pi W0 or 0W to the network. And then you can communicate with it by using a remote connection using SSH. Okay. All right. And I will show you, next I want to show you on your Raspberry Pi 4. You can do the same thing with Raspberry Pi 4, but Raspberry Pi 4, if you have the full desktop, it's a little bit easier to really navigate to it and, to be able to work with it. But you can also use the terminal. Okay. All right. Now, if I want to restart it because I installed something, I can. So in the assignment, it shows you, right, that you can SSH into your Pi without knowing its IP address using the host name or the IP address. And then you would need to enter the password. You have to press Y to accept and generate the key once you have that key. Now, if for some reason, if it shows, down the line when you try to connect to it again and the key doesn't work, then you have to delete the key and then reestablish the connection again by doing SSH with its IP address. And then, so if you have an old key and you're trying to establish, so for some reason, if let's say you had assigned a different IP address to it or rename your Pi, it's gonna want to it's gonna tell you that the key that it has is no longer valid, or you might be having man in the middle attack or some kind of error message, then you would then have to remove that key, and then reestablish the connection and recreate a new key. And you can always recreate a new key. And in cloud systems, when you're thinking about like having a server, on like Azure or AWS, you have to enable SSH on your Raspberry Pi in order for it to connect to so that way it can communicate. And through that connection, it would then utilize, the key process, and it's going to be able to communicate. I'm having a little bit low bandwidth, so I'm going to turn off my video for a short time. Okay. So once you establish, I took a screenshot of it so you can see that there. Once you establish the SSH communication, you can take a picture of it from your smartphone or your webcam, and then that's what you're going to use for this particular assignment. That's all I require today, or since yesterday. I just want to make sure that we're on the same page in case you want to use your Pi 0, you know how to be able to set that up. Okay. So next, I'm going to walk you through your Raspberry Pi 4 on how you can establish SSH with your Raspberry Pi 4. So I'm going to come back to my Pi 0, and then I would tell it to shut down. And in Linux, most releases, you can say shut down now, and it's going to understand that you want it to boot it down. Some other Linux releases, you will have to say shut down 0, because the value that you put next to the command in some other releases, it means the priority. So immediately means 0, and then there are other values that you would then wait to shut down, or you can give it a period of time and so on. So set wall messages, interactive authentication required. Yeah, I didn't want to do that right now. Let me see why. So while I'm troubleshooting, do you have any questions for me? Yeah, it wants me to re-authenticate, so I'm just going to close this out. Oh, because I'm on another session. Sorry about that. So let's try to... Yeah, I have 2 SSH sessions going on at the same time, so it doesn't like that. Okay. All right. So while we get our Raspberry Pi 0 down, I'm going to go ahead and reconnect my Pi 4. Okay. Let me switch this on. The reason why I want to go over Pi 4 is some of you also will be we are going to use Pi 4 just to minimize. So the candidate yellow box, right? See my instruction on how to set up your Raspberry Pi 4 if you don't know how. And then I'll talk about some configurations. So tomorrow we are going to automate our Pi using WhatsApp, right? If you have not used WhatsApp before, then we can explore it tomorrow. But if you use it for messaging or calling, it's a common popular. One second. Okay. Let me connect to my monitor. So on the Raspberry Pi 4, you can use mouse, keyboard, and monitor if you have spare ones. And if you don't, because it has a desktop, so you can also use VNC, and then you can also use, let me see why it's not. You can also use SSH. Let me see if it's booting here. All right, we're in business. And so the procedure to add the script and the SSH file is going to be about the same for the Raspberry Pi 4 if you wanted to do some of that. Okay, I'm going to attempt to do VNC while I'm in Zoom share screen. It's not going to like it because it's using the same resources, so bear with me here. Yay. All right. Okay, so here is my desktop for Raspberry Pi 4. Let's say that we didn't add any SSH file or any script. You can do that similarly to your Pi 0. Just to kind of touch on some of the basic for those of you who didn't take the last class, on the upper corner, I know that when I finish the video recording, it cuts out the top anyway. You would see your wireless connectivity, so that way you can use that, right? It's next to the clock, next to the speaker on the upper right. You can use that button to be able to add it, to add your network. But we can also use our terminal, right? And so now, right off the bat, if you're not connected wirelessly and you're unable to see it, I recommend using an Ethernet cable and connect it to your wireless, your router, and then it should be able to obtain an IP address, and then you can SSH into it, similarly to what we've done previously. Another way that we can actually see the desktop, we would be able to use VNC. So you would then, sorry, let me type into here. You would do a raspi, or I'm sorry, sudo raspi-config. This allows us to really get into the configuration of the Raspberry Pi. So this opens up the prompt after we issue the raspi config, and sudo just means super user do. Since you're on as a user, you have to put sudo because you want higher privilege on the system. Now, on this, we cannot use our mouse, so we're going to have to use the arrow key on the keyboard. So you want to go down for the interface option. And if you want to connect to your Raspberry Pi remotely, you have to enable VNC, okay? And so you just have to go down to yes, and it already highlighted that for me, and then press enter to select it, okay? And then, okay, just press enter again. Now, if I want to enable SSH, I would then have to, sorry, go down to the interface options again, and then I would choose P2, and then I want to use the left right arrow key or use tab to be able to select my option. So we can select yes. Okay. So in order to use BNC, you have to enable BNC, and that's a challenge, especially when you cannot see it. So, you can enable SSH, connect to it, and then using the file that you drop in, and then make sure that it's on the network, and then you can configure your VNC inside the Raspberry Pi if you don't have a monitor. Okay, so once we enable the SSH, then you have other options on here, such as system options, and then you would be able to set up your wireless LAN. So let me go back. Okay, so I'm gonna hit tab. So when you go to Raspberry config, you would see this menu, and if you select one by pressing enter, it's going to take you here. To add yourself to the wireless network, you can select the first option, which is S1, and then you just have to enter the SSID, and then go down to OK, and then put in your passphrase. Okay. So I'm going to hit tab to cancel because I'm already on the network. So you can play with the configuration, like changing the password, etc. Just make sure that if you already established SSH, it's tied to the certain credential. So, but you can also generate the key, copy the key, save the key, so that way you don't have to authenticate to it ever again, if it's, the same information. Okay. All right. So now you see a little bit of the Raspberry configuration. You can also set the region by doing localization. So locale is going to tie to the language and location physically where you are in the world, just like how earlier we put US, right? So here we want to put in the locale information, and then it's going to ask you like to select, and then all you have to do is use the arrow key to go down to United States, and then you can set up the time, which is going to be Los Angeles, and so on. And then let's see. One of the important things that you need to really configure is your keyboard, because Raspberry Pi was developed in the UK, so it's using UK standard keyboard. So what you have to tell it that you're using the US keyboard. So you have to go to the localization option, and then you are going to go down to L3, which is your keyboard, and then you are going to select from the option there. Now, if I don't want to use this, I can definitely use the interface. So the same thing that you're doing there, you can click on your Raspberry Pi at the top, and then you are going to go down to preferences. Okay. Sorry, let me tap out of this. It didn't like. Okay. So as we were saying, you would click on your Raspberry Pi button, and then you are going to go into preferences, and then you can set your mouse and keyboard option here. Then you just hit the keyboard tab, and then you just choose keyboard layout, and then make sure that we are selecting English US. Because if you use the English UK, you're going to find that when you type, it's going to give you different symbols and things than you intended for it to be. So once you select the appropriate keyboard here, we are going to click OK, and then click OK there. Okay, so if you have the desktop, you can use the graphical user interface to navigate. And then the same thing with our with our configurations for our system. So if you want to change up your localization, you would then click on Raspberry Pi config, and then it's going to give you this interface. So it has display interfaces, performance, and then there's localization. And so you can set locale and everything here as well. Okay, so 2 ways to do that. Okay. So for the interfaces, you just see how we enable SSH earlier. It shows that there. We use command line, however, with the raspi config command. So if you want to remotely connect to your system, you can use 2 ways. You can use VNC, which uses real VNC on Raspberry Pi, and then it makes the Raspberry Pi a VNC server. Then you have to go on your computer and you have to install VNC Viewer so it becomes a client and it's going to connect to it. And when you connect, I will show you that shortly. So on here, you would be able to do SSH. So now if I wanted to know what my IP address would be, I can just do IP address and it would tell me. So I just have to look for my INET right here. Okay. And then on my computer, I can go and I can look for real VNC. And so if you're using Chromebook, you would then use the Android version. Google just announced that they're not gonna, after later this year, they're no longer gonna support real VNC on Android platform. So you can go and look for other type of VNC applications, and then it's gonna look very similar. So download the real VNC. Okay. Let me see. You want to do viewer. Okay. So you need to download VNC Viewer on your computer, right? And then choose the appropriate OS, click download. So there's the Android one. So if you're using Chromebook, you should use this version. Or you can go to Google Play Store and then be able to obtain the app there as well. Just have to look for Real VNC Viewer. Okay. So on the side of the computer, the system that's connecting to the Pi, you have to use the viewer. And then on the Pi itself, okay, you would need to enable VNC to make it a server. So on the viewer, you just have to use your IP address to connect to it by creating a new connection. So I'll show you what that looks like. File, new connection, and then put in the IP address of your Pi, and then give it a nickname, and then you're going to have to log in using Pi and then Raspberry or the user account information, the credential. Okay. Any question? Okay, so let's try, I'm going to try to do something real quick. Let's see if our SSH works. To Pi at 192.168.0.13. This is my Pi 4. So now I'm going to try to SSH into my Raspberry Pi 4, which is different than the Pi 0, as you can see with the IP address. So I want to establish fingerprint, yes. And then please type yes. Okay, and then the password. There I am. So now it's connecting to the terminal for my Raspberry Pi 4. So using command line to do SSH, you're not going to be able to see the desktop. If you want to use the desktop, you have to download something like PuTTY, and then connect to it. But it's going to be limited to this size window. I'm going to let you know because PuTTY, the way they write the application, the window that pops up is really small. So when you connect, you can see the desktop, but it's a lot smaller. So I highly recommend using real VNC. You know, but if you want to see the desktop via SSH, you can set that up. So here we just do 192.168.0.13. And then make sure that it is port 22 because that's for SSH. It is the number that's assigned to specific services on your system. So by default, 22 is your SSH. Okay. And then you also need to, so for your session, you need to be able to do that. And then you got to go down here for PuTTY. And then you have to to authentication, and then you gotta make sure that you check all the configuration for the authentication and also your host keys. Okay. Any question? So now you can see how that would be on a Raspberry Pi 4 versus the 0W. So we are going to mainly use Raspberry Pi 4 for this class because I originally wanted to use the 0, but since you didn't receive all the things that you're supposed to, we're just going to use the CanaKit Raspberry Pi 4. And then if you want to end your SSH session, you can just type in exit. And then it's bringing me back to my command line, as you can see. Okay. So I'll close this. Any question? So one of the areas that we want to really, let's do clear screen. My video goes up on YouTube. I don't want some of the information to be floating around too long there. Okay, so this is my Raspberry Pi 4 terminal. So you can do updates by doing sudo apt update. And every time that before you install any kind of tools or software, right before you install it, you should update your Raspberry Pi. With that, what it's going to do is going to pull necessary firmware and any kind of updates to the operating system, and it's going to be able to push that. And then also recommended that you also do sudo apt upgrade. Okay. With that, it's also going to bring in some of the libraries that it needs. So it's going to push a lot of the software side for the upgrade. Okay. And as you know, that version changes all the time. So we want to make sure that we periodically do that or right before we install any kind of tool. Okay. Any question? So what I did was I included a document for Raspberry Pi 4 OS installation. You can find that on the second document that came from my other class. So I just pulled the steps. And then you should also install Python 3 and idle 3. So in case you need to program, which we will do a little bit. We actually use somebody's script and run it. But in case we need to edit the script, we would have the idle. So I have time, so I want to touch on that. Okay, so you can find the instructions there. Now, let's go back to our window here. And so if you want to install, you would do sudo apt get, because it has to go and get the packages, and then it's going to open up the packages to install. So you would then do the sudo apt get install. This is for Debian Linux, right? And so we can say Python 3 and idle 3. So idle 3 is a an IDE, which is integrated development environment where you can write your code and run your code. Um, and so this is it, idle comes default with Python, and so you want to be able to pull that. Okay. All right. Yours might take a little longer because I previously had installed the 3.7.3, which is a stable version. And then if you want to clear screen, you can type in clear and it will clear screen. On Windows, it's CLS. On Linux, it's just clear. Now, if you want to explore other IDE, I have some email coming in asking about, um, using idle is okay, but it's two separate window, maybe wanting to use other. Tawny is a Python IDE. With that, you can install packages within the IDE itself. You can also use Genie. So I'll show you what Genie looks like. Okay. It will be like this. So you very similar to Tawny, you can write it and then you can save it and then you can run it. Okay. So you would then be able to build it. You can build projects. So it's similar to NetBeans and some of the other ones out there, but very simple. The way that they make for Raspberry Pis, you don't have all the extra bells and whistles because that takes up space. So you can see some of the options. It does have some debug functionality and things like that, but um, you know, you can modify the way you want it to look. Okay, and then the other one is Tiny here. So you write your script at the top, okay, and then you would then see the output here as it runs. So the shell is on the bottom and the script's on the top. Compare that to idle, okay? Sorry, let me pull this down so you can use the button. Or compare that to idle if you call on idle. First, you're going to see this is a shell. So in shell, we can do like 2 times 8. It's going to give you the calculation. You can write in like a statement or a set of statements, and it should be able to execute it because Python uses interpreter and it interprets each line. So let's say we want to import 0, 3, and then because I didn't have that installed, so then I would want to come over here, and then I would want to say pip 3 install and the package's name. Okay. But for if I want to write the code, I would then have to go open up new file, and then I would then start with, from, a package, let's say NumPy import, and you can start importing in like pieces of the NumPy, and so you can write your script following. Okay, any question? Okay, so when you run your script in idle, it would show over here. The reason why I go over this and it's review for many of you is because some of you didn't take the other classes, and then we want to be able to write some script tomorrow or test some script tomorrow. So I want to make sure that you know how to install Python 3 and you know how to be able to modify your script and be able to run it. Okay, so once I have my script written, I just click run, and then or press F5, run module, and then I would see the output over here on my shell if you'd be using idle. Any question with this? Okay. And just like all the other system, you have the browser, you have file management. Okay. So by default, if you click save and not pointing to a certain directory, you would find it under the home directory and then pi underneath that. But if you want it for like other directory, you got to make sure that you point to specific directory. And if you do it from command line, you just got to make sure that you would navigate to that path by doing change directory, CD. All right. So that's like super basic with just command line and, knowing how to use the IDE, how to install some of the things. Um, so that just gives you the brief overview. Okay, any question? Now on the Pi Zero, you can do a recommended desktop version, but it's going to be drastically slow. I just want to let you know that because I think it comes with like 512 megabyte of internal RAM. Um, and so most of that is going to be utilized just to pull the desktop OS for you on the Pi Zero. It's very small. So even when you go through the installation process with the desktop, it's going to be slow. But what if I have only the light version and I want to install desktop? There are ways that you can install new GNU desktop, or if you use other Linux version, you can bring in different desktop, because the way that they design the operating system is you can modify your desktop by using desktop packages. You can use KDE desktop, which is developed by a different entity. So you can bring in, like, so for example, if you're using Fedora Linux, you can modify it, or if you're using Mint, some Mint version comes with specific desktop, but if you don't like that, you can install other desktop. Um, KDE is often used, and you can also use KDE for development desktop, where you would have more so on. Yeah, I'm getting a little lag on my side right now. I'm getting like low internet connection in the afternoon. Okay. Other questions or any comment? Okay, so tomorrow and on Thursday, we are going to use Raspberry Pi 4. I just want you to make sure that you have it set up. If you haven't, you can work on that. The instructions are there. Make sure that you put Python on it, and you can run some updates and upgrade. Um, I don't want to steer away from Pi 4 because it just simplifies some of the things. Some of you already got it set up. But if you having anytime that you're having difficulty um, with setting up your system, if you're running into and you tried so many times, and if you're having challenges, make sure you let me know and I can help you. Um, because sometimes I write general instructions for certain OS platform, and then when you try it, with Chromebook or something, and that doesn't work, make sure you communicate with me. I also have office hours right after this class. So, if you want to pop in there and I can, look at your screen and tell you what happened or help you with that, I can definitely do that. Okay. We're not using too many. So I was looking at the projects that you can do, and the feedback that I received from Adrenal and the earlier two classes, I think I wanted to unfortunately, we're not having all the equipment that we need. And so in case you don't have the equipment, I don't want to put you in a position that you have to get it, you have to buy it, or if you have to drive, I don't want that to happen. So I think I want to stay away from using a lot of the electrical circuits, but there will be option for you. So if you do have the equipment, you can incorporate it, but if you don't have the equipment, you can still write the actual script and run it and be able to do that. So that means that we are going to use a lot of the libraries. We are going to use a lot of the software tools and the API. So one of the things that I was looking at, and I'm finishing testing it now, is to be able to respond to messages on WhatsApp. So if somebody sent you a message, it's like auto reply. You can actually write the script for the Raspberry Pi to do that, and we are going to test that out tomorrow and Thursday. Okay. And then setting up like, online radio server or audio type of server. So we would do more on like a little bit of networking and making sure that it's connecting to the internet, that hence the IoT. But I also encourage you to think about how you would design your IoT systems, taking some of the exercise that we do. And then if you want to, write your own projects or, explore your own projects, I will allow that. Okay. So instead of doing lab and you're really curious about doing other things, just keep in mind that tutorials and instructions are not always 100% working. And because if they posted in 2016, 5 years later, libraries have changed, things have changed. Also, if they wrote it in Python 2 and you're trying to use Python 3. So making sure going into a project, really looking at the information that's given to you and also researching it is going to be, is useful. Um, a lot of times when I write these exercises, right, I'm using, open source material, but at the same time, I have tested them thoroughly. Like I have gone through it and I troubleshoot a lot of these things, and it does take a lot of time. So it's not something that, you can just sit down in 30 minutes and be done with. Um, so keep in mind that if you choose to do projects, that you really like, you have to take a look at, the resources that you have, time, effort, equipment, and then especially, how accurate is the tutorial that you're receiving from the internet. Um, even on raspberrypi.org, sometimes some of the stuff doesn't work always, right? And they don't always update it right away. So you would find that it would be um, taking a lot of time just to fix a problem. So when we did the Arduino, silly putty or the paperclip, some of you use paperclip, some of you use foil the piano. When I wrote that particular project, I used somebody's material, but I had to add a lot of the things and all the additional instructions. I modify a lot of the stuff, so that took me a few days alone. So just to let you know that some project can take a lot of time. Okay, and then if you want to 3D print something, you can. All right. So some of the things that I wanted to kind of touch base with you is um, just left my mind right now. Oh, after having a conversation with David, I think he's in cyber camp right now, but um, one of the projects that I'm considering is to use Pi-hole. This might be done at the end because just like Pi-hole or some of the console, and so it is when you're using something like this, sometimes they're not just library, they're actually a full image. So if you do like RetroPie, you actually download the full entire image that has, the application interface and all of that good stuff. So I might be considering this particular project just to kind of give you an idea, but you don't have to do it if you don't want to. So it gives you a little bit more understanding on how to really set up something that will be web-based, that would use domain name system or domain name service, which you really ties to like all the domains that exist out there, like google.com. So DNS always go with web servers when you're looking at like, different sites that you visit. And so, we can take a look at Pi-hole. And this usually Pi-hole is used to like block ads, right? Like when you visit a site, all these ads pop up because your browser is always listening unless you go incognito or you enable your privacy protection so that way it doesn't look at your search pattern or listen. Sometimes it actually utilize your microphone and also your camera, in some of the apps. So what you would, you can do is you can actually utilize tools to be able to block things so that way you don't get the annoying ads or things that you don't need when you establish that connection or use that service. Okay. So I was thinking of using this one. I'm going to revisit the Spotify one. I actually used that one when I was at college in the desert, which was years ago. And it works mostly okay. The challenge back then was ALSA audio functionality. So now that I saw that, you can use other library and there are additional resources. So that might be a good one to kind of do. Um, the challenge is, if you don't have Spotify services, that might be an issue. So I'm going to try to look at things that we can actually use that's already cloud based, or we can also connect to the cloud. But there are students in this class that might not be able to access those type of service. So I don't want to put somebody in a situation that they have to use it or they have to pay for things because non-credit card class is supposed to be very affordable or free mostly. Okay. Any question or comment? And so I also looked at, you know, maybe do like a Minecraft Pi server because we did Minecraft in the other one. But on the, if we set up the Minecraft server, other people can connect and play with you versus, the other one in the other class, we actually program pieces of Minecraft actions or objects. So yeah, so I'll put together a good compilation of activities and you can also choose. And if you have something that you really wish to do, you can send it to me and then I'll take a look at it and I'll see if we can attempt it. Okay. And then some part next week, we'll talk about how to really build some of these boards, using 3D printing. I had also requested previously to print traces on metal sheets to build out, uh, your microboards, but they never got around to purchasing those type of printers. So I'll revisit that and hopefully we'll be able to utilize the next part of the grant upcoming year to be able to buy that. So, okay, so just to wrap up, right, I will be available until 4 o'clock in case you need help. But go through the steps, set up your Pi, whether you want to use 0 or Pi 4, that's up to you. And then as soon as you are successful with SSH communication, take a picture. That's what you are going to submit for week 1 assignment. Okay, so I'm going to take it a little bit slower in this class because we are doing larger projects. So I want to make sure that you are ready to go when we start entering the project tomorrow or Thursday. Okay. Okay. All right. So that's all I have. Let me see anything else that I need to make sure that you know or understand. Okay. Nothing. Yeah, so I added some announcement if you are interested in getting an adapter so you can hook up your monitor to your Pi Zero. iMake Innovation Center, they did find some that they actually took a part from the kit. So you can call and let them know that you want to pick it up. But I don't want you to keep going back over there to get stuff. Gas is costly and your time is valuable. So you don't have to do that if you follow the instructions on how to configure it without having a monitor using your laptop or your system. Okay. All right. Any question? Okay, so we finished a little early today. I'll stay on until 4 p.m. in case you need help or have questions or whatnot, right? I'm going to stop recording so I can post my video after class, but I will also be available from 4 to 5 in a different Zoom link for office hours in case you need help or have questions or concern.